In this chapter, we are studying about Newton's third law. In this Newton's third law, you can see that a person is jumping from a boat. Now he is kicking back to the boat. Boat is coming backward direction. Person is coming forward direction. In a rocket, you can see the water rocket over here. Water will comes down and the bottle will go stop. In a cannon, ball will comes front, cannon will becomes backward direction. So while the three observations, what we have noticed, whenever one body exerts a force on another body, the second body exerts an equal and opposite force on the first body. Or every motion, there is an equal and opposite reaction. This is Newton's third law. You can see there is an activity. Request two children to stand on two separate carts. Give them a bag full of sand or some other heavy object. Ask them to play a game, catch with the bag. Does each of them receive an instantaneous reaction as a result of throwing the sandbag? You can paint the white line on cartwheel to observe motion of the two carts when the children threw a bag towards each other. Now there is a question. Does each of them receive an instantaneous reaction as a result of throwing the sandbag? Yes. When a body pushes the bag towards the girl with force F, the bag also pushes the boy in opposite direction with equal force F. Now, when girl catches the bag, she has to apply the force F to stop the bag. Hence, the bag also applies equal force F in opposite direction. So bag is going forward direction, girl is coming backward direction as a final position. Next, conservation of momentum. While rocket launching, we have noticing conservation of momentum. Momentum can never be created nor be destroyed. It can only be transferred from one body to another. When two or more bodies act upon one another, their total momentum remains constant, provided no external force are acting. Suppose two bodies A and B having mass m1 and m2 respectively are moving in the same direction, but with the different velocities u1 and u2 respectively. Let u1 is greater than u2. What happens? Absolutely, ball A will collide with ball B. At the time of collision, both are applying equal and opposite forces. Now, the total momentum before collision is equal to total momentum after collision. So, m1 u1 plus m2 u2 is equal to m1 plus m2 by v over here. Now, the common velocity v is equal to m1 u1 plus m2 u2 by m1 plus m2. Now, take a rubber balloon and inflate it fully. The neck using a thread, also using adhesive tape. Fix a straw on the surface of this balloon. Pass the thread through the straw and hold one end of the thread in your hand or fix it to the wall. Ask your friend to hold other end and the thread are fixed to the wall at some distance. This arrangement as we showed here. Now remove the thread, tie on the neck on the balloon. Let the air escape from the mouth of the balloon. Observe the direction in which the straw moves. Now, does the straw move? If S, in which direction? Of course, S, the straw moves and in the direction opposite to air exits. Why does this happen? As the air filled in balloon exits from the nozzle, it has some mass and velocity, hence momentum. Now, by law of momentum conservation, to balance this momentum, the balloon has to move in the opposite direction. Take a test tube of good quality glass material and put a small amount of water in it. Place a stopcock at the mouth of it. Now suspend the test tube horizontally by two strings or wire as shown. Heat the test tube with a burner until water vapors and cork blows out. Observe the test tube's recoil in the direction opposite to the direction of cork. Why does the test tube recoil and it which direction? Heating the test tube causes the water vapor and creates pressure, which makes cork blow out. Blown cork has some mass and velocity. Therefore, it possesses momentum. To balance this momentum as per law of conservation of momentum, the test tubes recoils the direction opposite to the cork. Let's see what we have understood. A bullet of mass 20 grams is horizontally fired and velocity 150 meters per second from a pistol of mass 2 kg. What is the recoil velocity of a pistol? Option A, 3 meters per second. Option B, minus 3 meters per second. Option C, 1.5 meters per second. Option D, minus 1.5 meters per second. Answer is minus 1.5. We'll see how it is. The mass of a bullet M1 is equal to 20 grams in the question. Convert into kilograms, 0.02. Mass of a pistol, 2 kilograms they have in the question. So initial velocity of a bullet U1, pistol U2 is equal to 0. So the final velocity of a velocity of a bullet V1 is equal to 150 meters per second. Let's say V is the recoil velocity of a pistol. So you know the total momentum when the gun is at rest 0 kg meters per second. The total momentum after it is fired 3 plus 2v kg meters per second. According to law of conservation of momentum, total momentum after the fire is equal to total momentum before the fire. So 3 plus 2v is equal to 0. So v is equal to 1.5. So finally, in this chapter, we are studying about laws of motion of a force. So there is a mapping. Thank you for visiting the channel. Thank you so much.